Hello and welcome to the Innovating Coastal Resilience Summit. My name is Sharon Ryan and I'm your facilitator for this afternoon. If you're joining us for the first time, we're delighted to have you with us. And if you've tuned into previous workshops, welcome back, and we look forward to another stimulating conversation with you today. So this week's deep dive will be on envisioning the future of coastal sensing technologies. And as with previous workshops, this session is being recorded and we'll post it on the Summit website in a day or so. So my co-hosts for today are David Kaplan and Amanda Smith. And David is on the Summit organizing team, and Amanda is going to be helping out with moderating the chat for us today. So David, I'd like to invite you now to say a few words about yourself and a little bit about the overall goals for the Summit.
Sure, thanks Sharon. Hi everyone, my name is David Kaplan. I'm an associate professor at the University of Florida. And I'd like to thank all of our speakers and participants for coming out today. It's great to see such a mix of folks across agencies and industry and academia. So just as a reminder, the overall motivation for this summit is to bring people together around this idea of the potential for technological innovation, and be that communication platforms or sensors or data analytics, to really support a healthy and vibrant coastal community and ecosystem. We really also hope that by coming together, we can develop new partnerships and collaborations among the academy, industry, and agencies, really bringing people together who are working on these challenges. So just as another reminder, the organizing committee, the partners here are Florida Agricultural Mechanical University, Mote Marine Laboratory, North Carolina State University, and the University of Florida. So I want to thank all of our organizers for pitching in to help pull this off. So thanks, I'll hand it back to you, Sharon.
Thanks, David. And everyone, please, if you haven't done so already, go ahead and introduce yourselves in the chat and let us know where you're coming from as well, which organization. And please also respond to, I think we have a question up already, or we will shortly, in the chat box. So please start your responses to that question as well, and we'll come back to that a little bit later. So while you're doing that, I'd like to invite Amanda, to my other co-host, to also introduce herself and go over a few housekeeping items with you.
Hi everyone, hope y'all are having a good day. My name is Amanda Smith and I'm with the Nature Conservancy. I'm helping Sharon with the chat here today. So I'm just going to quickly share my screen and show you how to use some of the Zoom meeting functions. So if you could see at the bottom of your screen, there's a ribbon where you can, that has all these different buttons. You can mute and unmute yourself. You can turn it on and off your video here. You can also use the chat function to ask questions and interact with other people on this call. If you would like to raise your hand for a verbal question, you can click on the Manage Participants button, which should list all the participants, but then you'll see this ribbon down here where you can raise your hand, and I'll be looking out for folks who are raising their hands so that you can unmute yourself and ask your question directly to the panelists. Thanks all.
Sharon, you're muted. Just unmute.
Thank you. Thanks, Christine. Thank you, Amanda. There's many different ways you can contribute today and engage with the conversation. You can talk to us in the chat box. You can raise your hands, ask questions. Also, we'll do breakout groups, and there will be an opportunity for filling out and completing an exit survey as well. So we appreciate any and all participation from you today. So one of the high-level goals for today's workshop is to gain a deeper understanding of water quality issues and to learn about some of the latest tools that are being used in monitoring and mitigating coastal water quality hazards. We'd also like to stimulate some thinking around the future of water quality sensors and pinpoint some of those urgent water quality hazards for which innovation in sensing tools is going to be key for enhancing our preparedness and response. So we'll do a quick run through now of our agenda. I'm just going to pop that up on the screen for you. So once we get through our introduction here, we'll go into 4 quick presentations on, that'll last for about 40 minutes. And during the talks, again, please type any comments, reactions, or questions you might have for the speakers in the chat, or any thoughts on the content that you're hearing. Our first presenter will be Jennifer Dorton of the Southeast Coastal Ocean Observing Regional Association, and she's going to be talking about the status of ocean monitoring in the U.S. Southeast. Next up, we'll have David Arnold, who will give us an overview of innovations happening at the University of Florida's MIST Center. We'll hear from Avni Argan of Geiner Inc., who will review current tools for rapid detection of marine toxins. And lastly, but not leastly, Stephanie Smith of YSI Xylem will share her perspective on the future of water quality sensors. So a warm welcome to all of our speakers again this week, and thank you for being here. So once we've heard all of the talks, we'll field a couple of your questions for the speakers. And if you would like to speak, just a reminder, you can raise your hands by clicking on the participants button, and I'll call on some of you to ask your questions. So after that, we'll move into breakout sessions at 1:50 for about 20 minutes, where we'll invite you to share your expertise on the topic at hand. At 2:10 p.m., we'll bring everyone back to the plenary group, and we'll invite 3 to 4 of the conveners to share some of the highlights from their group's discussion out loud and in the chat as well. Before closing up for the day, we'll share a link to a follow-up survey where you can expand on your comments. We'll also leave the chat open for about 15 minutes or so for anyone who'd like to add more comments there. And we'll wrap up this afternoon's session with a few words on next steps and upcoming workshops. And some of our speakers and organizers have kindly agreed to stick around after the sessions for a little while as well, and they'll be happy to answer any of your questions and chat further with you. So without further ado, I'd like to invite Jennifer now to begin her presentation. Thanks.
My name is Jennifer Dorton, and I work with the Southeast Coastal Ocean Observing Regional Association, or SOCORA for short. And today I'm going to do a bit of an overview about the current state of ocean observing in the Southeast. And I will say this kind of takes a heavy dive into data also, just like the volumes of data and how do we use that, because having observation are great, but then how do you handle the data from them and how do you effectively use that data? So just a quick little overview. SOCORA is part of a national program. We are part of the NOAA Integrated Ocean Observing System. NOAA is one, or IUS, as we affectionately call the Integrated Ocean Observing System, has 11 regional associations, and we all work with stakeholders to ensure that we're collecting data in locations and at scales relevant for their needs. So SOCORA operates in the Southeast. You can see it's down in the bottom left or bottom right corner of the U.S., but we have an overlapping boundary with the Gulf Observing System. So we cover from the North Carolina-Virginia line all the way around to the Gulf of Mexico and the state of Florida on the Gulf side. So we do have a pretty large area, 4-state area on top of it. So SOCORA, basically, we are ocean scientists and stakeholders, and we try to collect ocean and coastal data to understand our environments. SOCORA directly funds data collection activities that are undertaken by our partners. So I'm going to discuss some of that data collection on the next few slides. Our overarching goal is to make sure that the data and information we collect is relevant to our stakeholders and assist them with decision making. So at a basic level, that could be providing marine data that allows a boater to know if conditions are acceptable for going boating. At a larger scale level, we foster collaboration and data collection for local, state, and federal agencies to make decisions such as providing harmful algal bloom forecast or harmful algal bloom tracking. So we kind of go from small scale to large scale collaborative projects for the data that we collect. So traditional observations that SOCORA supports include moorings. For those folks in Florida, you probably are aware of the USF, the University of South Florida moorings out off the Tampa coast area. We also have moorings in North Carolina and South Carolina that we support. We have coastal stations such as water level stations. We have several of those in the Tampa area as well as in South Carolina. And we also fund high frequency radar. High frequency radar, we've got some of these stations have been in operation for 20 years or more now, and they do surface current measuring across North Carolina, South Carolina, Georgia, and Florida. We still have some gaps in coverage for high frequency radar, but we are slowly filling those gaps. Many of the, many of the observations, not just the HF radar, are pushing 20 years. I know for USF and UNCW that operates moorings, they've had stations in the water since the early 2000s. We also are supporting newer technologies. In the last few years, we've been doing a lot more glider work. Gliders are used to monitor three-dimensional water properties. They collect tag data from tagged fish. They are used to help monitor conditions before, during, and after hurricanes. And they have a lot of utility. They can do a lot of data collection across large spatial scales in a relatively short amount of time. And gliders are a lot cheaper to go out and operate than, say, ship-based surveys. We also have moved into the acoustic receiver side as well. So we've got fisheries folks that we work with who have tagged fish. They ask if Socorro might be able to partner, and they could put some of their acoustic receivers on our moorings to help them fill gaps so that they can more effectively track fish. So we are starting to use acoustic receivers now so that we can help partners such as the FACT network keep track of the animals that they tag. And what we're also seeing in the Southeast is that a lot of new technologies are coming on board. A lot of these technologies are a lot lower cost than traditional sampling methods. We're seeing web cameras being used more and more, not just for looking at the surf conditions to decide if you want to go surfing today, which they're great for that. But we've got folks that are developing algorithms so that you can standardize the data pulled out of web cameras and then be able to use that to look at coastal process and look at coastal change after storms. Drones are everyone's starting to see drones come up as a topic of conversation, whether it's ethical to use them or how do you use them and how do you get permission. So a lot of those conversations are going on in the Southeast right now, but we do have folks that want to use drones to identify post-storm erosion, harmful algal blooms, and other phenomena where it might be hazardous for people to go in and do any kind of monitoring. Then wave gliders are coming on board, sort of like your other traditional subsurface gliders, but these do stay at the surface. And waves are used to power that glider and allow it to go and monitor. And then we have a lot of low-cost sensors that are coming on board. Water level sensors are one that you guys may be more familiar with, some of the lower cost water level sensors. And but any of these are sensors that are lower in cost, easy to deploy, and are useful for community decision making. One thing I want to stress is sometimes when we think about observing technology, we always think of it in a science standard kind of way, where you have to have data to millimeters or even less of accuracy. But sometimes for coastal areas where flooding is prone, just really having a good estimate that might not be quite to the millimeter or quite to an inch level is sufficient. So we really need to also think about what type of data we need to collect and who it's going to primarily be used by and what decisions they need to make. So one thing that we also do is when you have a lot of data you collect, you got to make certain that it's quality controlled data. We do a lot of work with the IU's QUARTOD, which is the quality assurance for real-time data and quality control measures standards group. They put out manuals. I think there's 14 or 16 manuals available right now that allow folks to go in, identify what flags are required, what are recommended for any data stream that they have coming, that they're providing. So these quality control standards allow people to appropriately flag data and make certain that when folks are using that data, they know whether it's failed, passed, or if the data might be suspect. And then you also have to manage all this data. So in the Southeast, we actually do have a lot of data coming from a lot of different in situ and mobile platforms. So we really need to work with stakeholders and partners to include their data. So not just say Socorro funded data, but how do we work with stakeholders from other universities to make certain their data is seeing the light of day and that we're not just leaving data sitting on somebody's computer or it's only available, say, through Storette or some other agency. How do we make certain this data is more available to the community to help support decision making? So Socorro is really working with our stakeholders and partners to include their data on our data portal and in our data catalog to ease in discoverability and downloading of that data. And then we want to also make certain that data is available and you have a way to integrate, take an integrated look at that data. So you can map that data. You can pull it into data visualizations, Or if you just want to access data, you know, we do have a catalog with over 2,300 data sets that you can just go in and download that data and pull it right over to your machine to do what you need to with it. So I would encourage folks to take a look at least what Socorro provides, but if you are out there and you do a lot of environmental data collection and you're looking for a way to manage that data and need help with that, please let me know. So anytime we do a lot of data collection, whether that's from new and improved sensors, wave gliders, low-cost sensors, buoys, however we go out and collect data, we need to know why we're collecting that data. And so this is just an example of one of the activities that's going on in the Southeast and in the Gulf right now with a lot of different partners, from NOAA AOML to IUs, university partners, Socorro, GCUs. I mean, lots of folks are involved. But they're deploying gliders to help improve hurricane intensity forecasts. So if you look, this is kind of small, but up in sort of at the top of your screen, you'll see National Hurricane Center track error. You know, that purple line on the very top is, you know, 120 days out. There's a lot of track error. But when you get within 24 hours of a hurricane, they're pretty spot on the track. But to the right of that is the intensity forecast. Even 24 hours out, they're having a hard time with intensity. So one of the ways they're trying to improve that intensity forecast is do a better job of looking at water temperature and salinity throughout the water column. Gliders are a great way to do this. They can go out, they can be deployed during a storm. They're perfectly fine and happy, you know, tootling along during a storm. But that allows the Hurricane Center now to start getting some subsurface data that they can pull in, and hopefully we'll see improvements in that hurricane intensity forecast. So overall, our goal when we put any instrument in the water, ultimately, hopefully we're improving decision making. So whether that's for hurricanes, or if it's for beach water quality modeling, or if it's for just marine weather, everything we're doing, we really want to make certain we know exactly what data we want to collect, what the best instruments are to do that, how the stakeholder wants to use the data, and hopefully make certain we're getting the data to them either as raw data or as some kind of data product that they can use. And overall, a lot of data needs to go into helping us share resources. And I'm going to move on along here because I'm going over time. We have a lot of data in the Southeast, but there's some overarching questions like, how do we identify data gaps, both in stations and data types? How do we fill gaps? How do we make certain everybody's QA/QCing their data to a certain set standard? And then which data sets should we be using, and which, you know, how do we share this data? So, sorry, I think I went a few minutes over.
Thank you so much, Jennifer. David, we'd like to invite you now to give your presentation, please.
Thank you for the opportunity to come and talk. I'll take a little shift in gears here and talk not about a specific innovation in sensing, but really a framework that helps facilitate research and development between university academic participants as well as industry and government. So I am the Deputy Director for a center here at the University of Florida, led by the University of Florida, called the MIST Center. And MIST stands for the Multifunctional Integrated System Technology. So I'll explain a little bit more about what we are, but we are one of several dozen centers like ours that are funded by the National Science Foundation. Our center started in 2014, and the type of center that we are is called an IUCRC, and that stands for Industry University Cooperative Research Center. So our particular focus is on innovations in hardware technologies. That includes sensing and communications in the IoT era. And so the Internet of Things, and you hear a lot about this these days, it talks about, you know, smart oceans, smart homes, smart parking, smart cities. At the bottom of this ecosystem is the actual physical components that make this happen. This would be things ranging from devices like you would find in your phone. This would be the sensor technologies, but also the computing, the imaging, the data interfaces, and the wireless connectivity. So our center is focused really on these hardware technologies at the root of the forest that makes up what people are calling the Internet of Things. Now, the way that an IUCRC center like ours works is tries to leverage what universities are good at and match that with what companies are good at. So universities are great at innovating fundamental scientific discoveries, perhaps doing some early stage prototyping of ideas. And then companies, of course, are interested in deploying products into real world systems. And so many of you that know a little bit about tech transition, there's this valley of death, which happens because of a mismatch in the abilities and scope and focus of fundamental scientists over here and businesses and companies and maybe mission-focused agencies over here. So our center exists to help bridge this valley of death. And the way our center works is that we actually have 3 university sites, us, University of Central Florida in Orlando, and University of Virginia in Charlottesville, Virginia. We have a handful of, or a number of partners, both industry and government partners. And our partners buy a membership into the center. The membership dollars are pooled, and on an annual cycle, the members vote and select a portfolio of projects that are funded in the center. Now, the key advantage for this type of architecture is we use the brain power and infrastructure of the universities and match that with the technology needs by our member companies. A really important part of this is that unlike traditional funding of university projects, the members are charged a much reduced overhead rate at the university, only 10% overhead as opposed to the normal 50 or 60% overhead. So this is a very cost-effective way to execute early stage research projects. And I'll give an example in a minute. So we like to talk and sell the center on what we call the 3 R's. We offer opportunities for research, for recruiting, and relationships. And so specific to that, I'll give you examples on the next few slides. So the research expertise, you can imagine our 3 institutions are 3 very large, prominent engineering schools. We had access to several tens of thousands of engineering students at the undergraduate up through the postdoctoral level. In our crew of, or stable of participants in our network, we have over 80 plus research experts with deep scientific technical expertise in a number of different technology areas. And so when you buy a membership into the MIST Center, you have access to all of the people in our network. Obviously, the physical infrastructure that's provided by the universities in terms of laboratory space, research test sites, et cetera. This is a quick picture of our roadmap, or sort of an outline of how our center works. Our center is focused into 5 specific technology thrusts, and that's things like sensing, wireless, computing, power solutions. And we try to fuse together innovations in these fundamental seeds into threads of systems, such as a wearable device or a smart sensor network. And then we feed these towards our member companies who may come from a number of different industry sectors, whether that's environment or agriculture, healthcare, automotive, et cetera. In terms of recruiting, a major value add to our member companies is the ability to interact not just with faculty, but also our many students who participate in the center. So in the 5 or so years that our center has been active, we've involved over 88 graduate students and over 35 undergraduate students in the various research activities. During our biannual meetings, we offer activities such as mentorship opportunities, resume, mock interviews, and also we have a pipeline that allows us to efficiently fund internships of our students at our member companies. We also have a number of activities focused on diversity and inclusion during all of our events. The real outcome and the real benefit that's a little bit more intangible is the relationships. So you can imagine consistent interaction between students, faculty, member organizations at government agencies, companies who may be suppliers to each other, vendors, or they might be competitors to each other. But there's an amazing amount of breadth of shared knowledge and interaction that happens through these interactions. So I'm going to take a minute and just go through one quick case study of a MIST-funded project that's active right now that has relationship to the technology coastal sensing that we're discussing today. So this is one particular project that's a wireless phosphate and pH sensor system intended for coastal monitoring, specifically water quality. So I'm sorry, I'm trying to manage a bunch of overlays on my screen here. This is a funded project by 2 faculty here at University of Florida, as it turns out. Professor Yoon is electrical engineer and Yoon Suk Lee is in physics, and their team of graduate students. This project is in its 3rd year of funding in our center. We fund projects in 1-year increments. and a typical project is funded at about a $50,000 funding level. All of our projects have industry mentors, and so these are companies and members of our center who have interest in the outcomes of the project. They also dial in and provide a monthly teleconference environment to give feedback and input and help guide and steer the project in directions that are of direct benefit to their organizations. So this particular project is funded by some, mentored by some smaller companies, as well as a larger organization that has an outpost in Orlando called IMAC, and most of you have heard of Northrop Grumman. So the specifics of this project, which are not so germane to what I wanted to convey today, but to give you an example, is obviously there's a need for a wireless telemetry of water monitoring. And specifically, we're interested here in phosphate, but you could also think more broadly as an NPK sensor plus pH, temperature, and other things for distributed in-field sensing. So the specifics in innovation is we try to bring the latest technology and know-how from engineering to solve such problems. And so this is a micro nanofabricated sensor device. It's a small stick of gum sized platform that has some exposed chemical electrodes here that are responsive to the different elements in the water sample that can do real-time monitoring. This sensor head is interfaced with a wireless telemetry module. In this case, it's Bluetooth, but we're also using LoRa and other cellular-based networks to feed back data to a central hub. So the details of this plot, this isn't my research. I won't try to go into too much depth, but this is a real-time measurement of the sensor response to pH changes. And so you see some transition period, but in a matter of seconds, you can get real-time monitoring of pH from such a sensor. And then on the right was showing the sensor behavior using the raw sensing elements to detect changes in exposure to potassium. In this case, a phosphate exposure. So what I want to mention is this is just one example. The MIST Center, as I mentioned, is in our 6th year. We've funded nearly $4 million in research in small projects like this. These projects oftentimes transition into a larger project that is absorbed into our member companies and further developed in-house. We have 94% membership fee efficiency. So 94 cents of every dollar our members have bought into our center have gone to direct research expenditures. I mentioned the number of students. There's also favorable IP and licensing opportunities with all of our projects. So we've filed many, not just publications, but patents. So the center has a portfolio of patents, and there's been licenses taken on those patents by our member companies. So I think that's probably a good snapshot of what I wanted to communicate, and I will turn it over to the next speaker.
Thanks, David. Lots going on at the MIST Center. I'd like to invite Avi now to start his presentation. Thank you, David.
While we're transitioning, if you have any questions for David or for Jennifer, please feel free to add them into the chat.
Good afternoon, everybody. My name is Avni Argun, and I'm joining in from Ginner Inc., based in outside the Boston area in Newton, Massachusetts. Today, this afternoon, I'd like to tell you a little bit about the efforts in development of sensors, the rapid and the local sensors for the detection of red tide toxins. And this is a collaborative effort between us and the Mott Marine Laboratory at Dr. Pierce, Dr. Loco, and their team. Ginner Inc., as I mentioned, we are an electrochemical R&D firm with fully equipped 20,000 square feet the laboratory space, and with small-scale in-house manufacturing capabilities. And we are made up of 3 companies. Ginner Labs is what I'm a member of, is the technology development engine, and serves as the incubator for our spin-off companies, which currently include an electrolyzer company, Ginner ELX, and our medical oxygen, the life science company, Ginner Life Sciences. The overall goal of our companies is the rapid commercialization of electrochemical sensors for environmental and healthcare use. Before going into our activities in the red tide toxin sensing, I'd like to give you an overview of what other the sensors that we work with and we are working on. One example is very closely related is environmental DNA sensor for bioremediation efforts. This is to detect bacteria that is important to soil, the soil and water, and this was in collaboration with also one of the faculty members in University of Florida Department of Agriculture. We've recently we have recently commercialized our personal alcohol monitor system, which is currently being integrated into a smartwatch for the monitoring of transdermal alcohol. And we have other R&D activities in the healthcare area, which include the transdermal CO2 sensor, as well as the monitoring of blood, the lithium levels in collaboration with Massachusetts General Hospital. That being said, what caught our attention was that the major problem that we've identified and we've addressed to NOAA as a challenge on the detection of the toxins in the seawater that are caused by harmful algal blooms. These cause over 60,000 intoxications every year, with an economic impact of $50 million annually, mostly on fisheries and the recreational beach activities and the tourism. And to make things worse, these are increasing in frequency. And currently, while there are a number of systems from the satellites or other type of monitoring with the lab equipment, there's really no device that will help with the frequency of the data that's needed and the resolution of the data that's needed to warn for the early detection of these harmful algal blooms. So we've identified that critical need to be a development of a rapid on-site and a low-cost toxin sensor that will help the fisheries, the regulating agencies, as well as the recreational beach users. So our solution to this was an electronic nose for recognizing a red tide toxin. We envision an instrument as shown here on the bottom right, where it's made of an instrument, a handheld instrument that's capable of connecting to a smartphone or a tablet nearby, as well as a disposable test cartridge that will allow for introduction of the seawater for the toxin measurement. We have developed a method for the detection algorithms for each targeted marine toxin, and very highly specific for the toxin that we intend to detect. And we were able to show at early stages that we can detect the red tide toxins, which are the Brella toxins in the case of the Southeast United States and the Gulf Coast, to be able to detect these in the seawater below their toxic threshold levels. And we're all aiming to do this in less than 5 minutes in a very rapid way, and also using a cheap disposables with the long shelf life. So just one slide on where we are. Our goal was to detect both brelatoxin 2, one analog, which is found inside the algae, and brelatoxin 3, that's found when the algae bursts and goes into the ocean water at very low nanogram per milliliter levels. And so this corresponds to about low to high hazard level, but that's currently defined for monitoring the red tide condition. And with this, we are aiming at not only detecting the toxins in the water to assess toxicity, but also providing a tool to determine which the stage of the algal bloom is, whether it's a fresh or peak or in a diminishing state, by monitoring these two different toxins. And we have practical measured the limit of detection of the 0.1 nanogram per milliliter, which is sufficient to cover the range that I mentioned before. So in the summary, with the funding from NOAA, we will develop this initial prototype, the handheld the sensor that has the comparable performance with the lab standard methods, but can also do it much faster and at a cost that is more relevant for the high frequency and high volume testing. One key finding and the takeaway point from this is that this was the first ever really electrochemical detection of the toxins in seawater directly using a disposable electrodes, and our ongoing studies with MOT currently the focus is on the validating with field samples that are obtained from the red tide samples. We have very recently expanded this platform to include shellfish toxins, and with initial seed funding from USDA, we're now looking into developing the sensors for octadeic acid and the domainic acid, which are the two major the causative agents for the shellfish poisoning, the illnesses, which affect a lot of people, every year, and this is also increasing in frequency because of increasing.
Seems like we're having some technical difficulties again with Avni. So in the interest of time, I think we should move on and ahead. And Stephanie, I'd like to invite you now, if you would, to share your presentation.
Very good, thank you. I want to thank all of you for inviting me to participate. Some really interesting talks that I think lead very nicely into a high-level overview of what we at YSI Xylem see going on. Obviously, this could be a lot longer than a 10-minute talk, but I'll do my very best. Just to understand, I want to kind of frame the context of my talk and what's going on today. And for some context, I'm really talking mainly about continuous multi-parameter platforms. That is pretty much the state of the art today for water quality sensing. And of course, the value of doing continuous monitoring is that unlike if you were collecting data weekly, you can see every 15 minutes is typically what a YSI user would be doing with an exosonde. You can see events that you wouldn't see with less frequent monitoring. So really the state of the art is to look at multiple parameters at a single point in time as frequently as you possibly can. And, we're getting now to where this is, almost in real time. The other thing that is sort of the state of the art, particularly for coastal monitoring today, is integrated systems with telemetry. We've seen some of that in the prior talk, so I won't belabor that point. But I will say that there's a lot going on with these systems getting more affordable and more accessible. But they really are state of the art today is to put an exosonde or even my competitors' sondes on these types of platforms to be making data available, similar to what Jennifer was showing, making data available to everybody as often as possible so you can visualize it in real time. But let's talk a little bit about sensors, actual sensors that are used in this context. Almost every monitoring platform, be it a buoy or whatever, will have these 5 parameters being monitored for water quality. We call these in the industry, we call these the big 5 parameters. It's pretty rare you wouldn't have all of these. Now I will say in some coastal monitoring, people might forego turbidity, they might forego DO, but I always advise that any monitoring program should be built on the big 5 parameters. But we are seeing now that more specialized parameters, people want to include those in those monitoring buoys. I talk a bit about FDOM and algal pigments in a lot of my talks today. In the interest of time, I'm going to stick to the algae. But for future reference, we have done a webinar series that's available on demand that goes into a great bit of detail about each of the sensing parameters you see here. And those are freely downloadable at the website that you see here. I'm going to give you a little bit of a taste for some of that for the algae sensor. So clearly this audience understands that when we talk about detecting algae in the environment, we're really not talking about detecting the algae, we're talking about detecting their pigments. Chlorophyll for many, many years has formed the foundation of algal monitoring technologies, whether it's going out and getting a grab sample and running it through a filter and doing an extraction in the lab, or whether it is using deployed sensors such as we produce at YSI. Chlorophyll, of course, is found in all algae. So that is one of the reasons it's the most widely used. The other reason really that was kind of all used to it. That's a little bit of a bad thing too, because we all expect all new data to look like old data done with different methods. And one of the challenges, and I think I even saw maybe Nikki Dix commented in the chat earlier, is that getting the data from these modern sensors to correlate with extraction data is a real challenge for our industry. And it's something that I'm really excited to see a lot of activity around. Now, blue-green algae, which are often the toxic algae that we're concerned about, particularly in freshwater systems, they have allophycocyanin and phycocyanin. We typically only talk about the phycocyanin for detection. And then marine blue-green algae also have phycoerythrin. So those are the three pigments we're typically most interested in. And a sensor itself, this is sort of the state of the art for an algae sensor. Obviously, I have a little bit of bias there. I think the YSI sensor is the state of the art. But the reason I believe that, there are a few reasons. One is that it is what is called a dual channel sensor. You detect not only chlorophyll, but also you detect either phycocyanin or phycoerythrin in the second channel. And that is being driven by specific LED technology. That's a big change in the industry. It's not a new one really, but these require a lot less energy than a lamp-based spectrophotometric type of detection or fluorescence-based detection. But of course, a lot of the magic in these sensors really happens in the filtering and the types of photodetectors that are now available that weren't available to our older platforms. So these sensors now are about 10-fold more sensitive. They're much less prone to interference from turbidity and other things that might be in the environment. And then the real secret sauce, though, happens in what we in the industry call post-processing of the raw data. We don't just take millivolts in and spit and convert that to a part per billion of pigment unit. We actually do some filtering of that data, and we have proprietary algorithms. That is what distinguishes one company's sensor from another. Besides just hardware and the engineering, it is really the software engineering that allows you to get more robust data sets. So we talk a lot about that in that webinar series. I want to give you a great example from your state in Florida. I love the ORCA organization there. They're using a lot of algae sensors and YSI sensors in general. And someone from that organization contacted me back in 2017. They do a lot of monitoring at a place called Sykes Creek, which is actually on the eastern coast of Florida. So we're not talking red bloom stuff here today. And they have typical conditions. Notice they do a multi-parameter approach to their monitoring. It ends up that things like salinity and DO actually have some importance in your algae monitoring. It's not all about the pigments. So there are conditions that they're used to seeing with a tidal pattern. And when they have a bloom, they typically see a modest increase in that chlorophyll channel, but a big peak of phycoerythrin. That's what they typically see at Sykes Creek. Now, they saw an unusual bloom though, around the end of the year in 2017. And I started looking at the data with them, and the thing they noticed that was most interesting to them is they saw sort of a concomitant increase of both the phycoerythrin and the chlorophyll. This is not typical of what they would see. So I asked, you could download their data online, which is really useful. And I started looking at other things, and I noticed that the pH was rising, rising, rising. as it often does with certain blooms. And you could see that how it mapped and continued rising and then started coming down as that blue-green algae line started coming down. This is the phycocyanin line. So I also noticed that there was a decline in salinity, and they had a really wide dissolved oxygen pattern with this bloom. And it ended up that this actually was a very unusual bloom. This is not the exact bloom, but it's an example. It was a brown tide, basically, event. And so that brown tide event looked a lot different than their normal events, and they could identify that because of this multi-parameter monitoring approach they were taking. So this is really state-of-the-art monitoring today. Where are things headed? There's a lot I could say here, but trying to wrap that up for you in a couple of minutes, David already talked a bit about smart cities and so forth. I've been trying to get people to use the nomenclature smart watersheds, because we shouldn't be looking at any system in isolation. If you're studying the coast, you need to be studying what's headed to the coast. And nobody knows that better than you folks in Florida who are looking at Okeechobee and the Gulf, right? So here's an example in Singapore of over 300 monitoring stations where they adopted our XO1 sonde platform. We kind of stripped it down and adapted it so that it could go right into their distribution systems. This is a phenomenal system. This is by the Singapore Public Utilities Board, but it is expensive. And that is one of the trends that David already mentioned, so I won't belabor it here, is to try to figure out how to do this a lot less expensively. The other thing that Jennifer also talked about is autonomous vehicles. She talked about gliders. We have an AUV called the i3XO, and we have a surface vehicle called the HiCat. People don't want to put people on the water anymore. So this is a major trend, is to go to autonomous vehicles, even with telemetry on the vehicles in some cases. And then the other thing that we're very excited about at YSI is that we are now accessing new LED technology that wasn't even available 5 years ago to start looking at sensors in what we call the deep UV range. So I'm showing you here what's called an excitation emission spectrum, an EEM spectrum. When we talk about fluorescence sensors, we talk about the excitation wavelength and the emission wavelength. And you can see here, for example, here's where the total algae wavelengths sit. Here's where a rhodamine wavelength sits. We're now getting to where we're working way down here in the deep UV range. And the most exciting development we have coming on that is related to a new sensor that YSI is developing for nutrient monitoring. YSI's nitrate sensor is taking advantage of new deep UV technology. It is an absorbance-based sensor, and it is low power. This isn't going to suck the kind of energy that the current lamp-based sensors available in the industry require. We can use it on the XO platform, adapting the XO platform with a specialized wiper and a way to secure this absorbance-based light path in the XO platform. So this is what I believe is the future of our technologies, along with trying to adapt to lower cost technologies and some of the things I showed you earlier. So I'll wrap that up, and we'll welcome any questions.
Thank you very much, Stephanie. We do have loads of questions in the chat for you, but also for several of the others. So would you like to finish up your last slide?
Hi, I think I already covered the basics of it. The last slide there was going to talk about our future collaboration with MODE on the capturing aerosol toxins, which is another important public health hazard. And we're also in talks with Dr. Tracy Fanera, who was one of our speakers last week, on incorporating our data into their citizen science system. Thank you.
Okay, great. Thank you so much. I'll just go for one question here, and then we'll have to move quickly into our breakout groups. So let's see, we have a question for you, Stephanie. Andrew Altieri would like to hear about the potential to integrate third-party sensors and devices into their telemetry buoy systems.
Yeah, that's an interesting thing that we're seeing. Where things start, so if you're doing it in a buoy system and you want to integrate that into an exosonde, what we are trying to develop for EXO is a way to use that auxiliary port, if you're familiar with that, so that you can get a third-party sensor actually communicating through the sonde and then up to your data logger. That is, though, an interesting question, because one of the things we're seeing, like when we talk about all these low-cost sensors, if those low-cost sensors are not integratable into an existing platform, you start running out of space on your data logger and your telemetry board. So really what we have to try to do with these low-cost sensor technologies is get them to work with existing platforms like EXO and other sonde platforms, or very, very fast, you run out of telemetry space and ports on your data loggers. So that's a really great question. There's definitely work to be done both on our platform as well as on the telemetry platforms in general, so that we don't run out of capacity on those buoys.
Great, thank you, Stephanie. I wish we had time for a bunch more questions because people are pretty curious about a number of different topics. So we'll try and come back to more questions at the end. Right now, we're going to head out into our breakout sessions. I'm just going to share a quick document with you. So as you can see from our, as soon as I get it up here. As you can see from the table here, we have about 10 groups today that will be addressing 4 questions in total. And the first groups 1 to 5 will address the first 2 questions. And we'll ask groups 6 to 10 to look at the last 3 and 4 number questions. And if you get through your set of questions, please feel free to answer all of the questions. I would like to let you know that each breakout group, will be facilitated by a discussion convener and have a note taker as well. And the note taker is going to share the document on the screen, and they'll be recording the conversation live. So I'll give you a 2-minute warning when time is up, and please use the last 2 minutes just to wrap up your discussion. You will automatically be brought back to the plenary, so please just wait for that to happen. And we want everybody to come back at the same time. And once you come back, we'll start a discussion around what people were talking about. Okay, so I'm going to send you off to breakout groups. Is everybody back? Trying to see, yeah, it looks like everybody should be back in the main plenary right now. So I'd like to ask one of the groups from groups 1 to 5, if someone could volunteer to share a little bit about the highlights that came out of your group discussion around questions 1 and 2 specifically. So we have Alan and Kim. Are either of you back? Would you like to share?
Sure. I actually just saved and removed my notes. So if you want to give me a moment.
Sure.
It was 3 of us because Joe had to go to another meeting at 2, but we were lucky and had Eva in our group who works for, oh God, I'm going to mispronounce this, but the German company that we actually use a lot in the Angelini lab. We use the bentho torch, which is made by BBE Moldensky. I'm sorry, Eva, you can correct me on that. But it was a great perspective because she's coming from a company who's actually making the instruments to collect the data. So it wasn't from the perspective that I'm used to as a scientist. Okay, like for question 1, what are we measuring and then what are we using it for? It was okay, what instruments should we be creating and what sensors are needed to measure what parameters? So for question 1 specifically, what coastal water quality hazards were we currently measuring using? How does the organization use that data? We essentially discussed the different instruments from their company. So mainly like a fluoroprobe or things to measure algae, but they have a variety of instruments from tools that can measure toxins to field instruments and water treatment systems. I don't know if Alan or Eva want to add to that, but that was the gist for question 1.
Okay, thank you very much. Would someone from the higher groups like to share? So groups 6 to 10, who we're talking about the last 2 questions. Let's see who's in those groups. Arnaldo, would you like to share?
There was a nice discussion about seeing a highly automatized system of data collection in 20 years, right? But there was also reaffirmation that it's going to be very difficult to give up the use of boats because there are certain processes in the coastal ocean that require actual direct observation, like the state of fish, of different, for fish kills, whether they're before they died, what they look like. So highly automatized system of measurements, but still, it seems that we're gonna still need to go out on boats. And another aspect is, in terms of the game changer, is the development of multi-parameter zones that record automatically parameters that we haven't even thought about yet that are required to be measured, like microplastics or other parameters that were mentioned that we don't consider yet. Right? And in terms of the other question, for to have a better trained population in terms of technology, there were several ideas proposed. The ones that come to mind are the ones proposed for K-12 stages, that robotics and electronics should perhaps become part of the main curriculum instead of being optional subjects in school, that people get better trained, and in that case they would get more excited about these technologies and maybe be better prepared for to improve the technology. And I think that's the essence of our conversations.
Great, thank you, Arnaldo, for sharing. That's really interesting. I'd like to ask Alex Beavers from Group 2. Alex, would you share some of your group's discussion with us?
Yes, I would just, so we had an interesting conversation about the quality of data. I think one of the speakers talked about different levels of data quality, and another speaker talked about how the software data analysis algorithms were a key differentiator in their products in terms of the usefulness of their instruments. And there's a consensus in our group, I think, about the fact that we still have a lot to learn about how to deal with sources of errors and things in our data that we don't fit neatly into a nice, clean, database environment. A lot of us data analysts like to see. So, and then also we're looking for causality factors from the data so that we can build better models and have a better understanding of where that might lead to in terms of forecast. But I think everyone's very excited about the growing amount of data being collected, but that's making our analysis and use of that data even more complicated.
Thank you, Alex. Tracy, would you like to share a bit about what your group talked about?
I'm Lauren. I'm going to share for Tracy. I've got the notes right in front of us here. So we were looking at what do we think coastal sensing technology will look like in 20 years. We had a pretty good conversation about Jetson style of technology and equipment, but we were really thinking more about the continuation of this conversation about sharing data resources as a comprehensive analysis. To really kind of hone in on what information and data is necessary for stakeholders to be making decisions, and kind of what data can act as warning flags. So what parameters should we be keeping an eye on if we're worried about a red tide incident? And we also talked about being able to organize that data in a dashboard style platform so that it's easy to identify some of these drivers that help stakeholders make specific decisions depending on their needs. And we also talked about, we think that in the future there's going to be an increase in the amount of data. And so being able to collect that data in a cohesive manner, like we were discussing earlier, is going to be super valuable for moving these different types of research fields forward. And then we also were thinking that kind of in the deeper water area and not just coastal systems, that AUVs will become more efficient, hopefully, and that could decrease inconsistent time between data streams due to planning for offshore cruises, and maybe also decrease sometimes the amount of offshore cruises that are necessary. And then we also delved a little bit into training that would be valuable in accelerating progress in coastal sensing. So a big thing was like what Arnaldo mentioned about introducing these coding and data and technology courses earlier in a K through 12 curriculum, so that these conversations are more comfortable and familiar for students before they really hit that undergrad level. And then of course, continuing the opportunity for undergrads to really get their hands on some of these sensors and to really feel and understand how they work and the data that they collect, so that they are more comfortable with it and more comfortable with using the technology, will then enable us to continue to collect more and better data. And then we're also thinking at the technical level, providing like really easily accessible information of new sensors and how they work and their capabilities, and maybe kind of doing that at like a UF university level and packaging that in a way that it can be distributed to professional engineers when they have to update their technical training courses, or for kind of technical or vocational schools to be able to use some of those resources that were created on a bigger platform and reach a broader audience.
Well, thank you, Lauren. I see that you guys answered all the questions. That was really great, very thorough. Appreciate that. Just being mindful of the time, we're going to have to head into wrapping up for today. We will, well, first of all, let me thank you all for joining us and for being here. And I hope that you've really benefited from and enjoyed the experience. In next week's workshop, we're going to be exploring how artificial intelligence and data science and data engineering can help maximize the value of data for decision-making in marine management. So please join us for that workshop as well. And if you'd like more information on upcoming topics and the summit itself, just click on the website link that's being posted in the chat. We're going to leave the chat open for about 15 minutes or so if anyone would like to stay and get some of their questions answered. Also, if you'd like to add more comments, we'd appreciate that as well. We're also going to be sharing a follow-up survey, and if you can click on the survey after the session ends and head over there and fill that out, we'd really appreciate it. Your input is very valuable. And so I'd like to invite David now just to say a few final words about next steps and next week, and then we'll wrap up, as I said.
Sure, thanks, Sharon. So yeah, thank you everyone for your participation. It's been a really good conversation about sensing. If you were on last week, you heard about the needs that were driving technological innovation. Today is about sensing, and then next week is going to be about, as a couple of speakers said, all of this data we need to get some insight and interpretability from. So the analytics and AI, that we can turn these data into information and understanding. So we'll be reporting back to you on the results of this and all of the webinars in the series. We have the summit ending on July 15th, where we're going to come back together to sort of discuss what we learned together as a group. And we hope you can join us for that, as well as joining us next week for the Data Analytics and AI webinar. You can leave your contact details in the chat if you haven't already registered, and we can help you make sure you get that information. And you're welcome to stay on the call now and talk about anything related to water quality or sensing. And if not, we hope to see you next week. Thanks again.
Thank you, David. Thank you, Amanda. And thank you all to all our speakers and participants today. And we hope that we will see you next week on Wednesday, June 24th at 1 p.m. Thanks and have a great day.